While his primary home is electronics, teaching everything from core concepts to robotics and radio communications, his range of expertise is wide. He also leads courses in business and project management for the BAS in Leadership and Management program. Chuck credits his middle school science teacher as a key influence on his intellectual development. He gave Chuck an open drawing book, a new pen, and encouraged him to examine and question everything. The spirit of exploration is what he tries to replicate in his own labs and classes today. Employing a flipped class approach, Chuck assigns his students topics and asks them to develop lectures and present to their peers multiple times throughout the term. This builds world projects and aligns his lab with professional industry shop workflows. He acts as a mentor so that students see the bigger picture of their future careers. Lastly, he has thoughtfully included generative AI tools in his curriculum, encouraging his students to interact with these tools ethically as an aid to critical thinking and problem solving, not as a replacement. Whether he is guiding a student through a complex circuit or navigating the ethics of emerging technology, Chuck's multifaceted approach ensures that his students graduate not just as technicians, but as well-rounded, forward-thinking professionals. Little did he know that when he gave me this t-shirt, it would become my uniform for my work here at WICL. So much so that recently at the Portland Ballet, people from WICL told me they didn't recognize me without my t-shirt on. Last year, I had the pleasure of being invited to hear students and Chuck share the work they are doing in the robotics program, and I just felt that everyone should hear this and know about their work. He has presented to INMARTECH, NOAA, Oregon Lottery, and has received over $200,000 in grant awards. Those of you who have been with us a while may remember some of his demonstrations of drones. Today, he is here to talk about the advancement of robotics in our constantly changing world and to demonstrate that with one of his many robots.
I guess it's on now. Thank you all for letting me be here and talk to you today. I was telling someone earlier that it was about 12 years ago. I was here before, but we did it over at the Willamette. And then Tokyo University after that. And I really enjoyed it, so I appreciate it. And it was kind of interesting back then, so a lot of my former teachers recognized me, as well as maybe some guidance counselors. So if you're out there, be sure and say hi to me again. I do blame Jim Worth. If you know Jim Worth, he was a teacher at Leslie Middle School. I do blame him. I still contact him quite often. He's up in Washington now, but he did inspire me to do all sorts of stuff that maybe my wife doesn't appreciate so much anymore. It includes lapidary, rocketry, electronics, all the fun stuff that I felt. Growing up in middle school was where I was able to really blossom and see, and I really feel that that is probably the one thing that we miss in many ways in education, is find those early on things with those kids in middle school. So that's why I try to go there. I try to go there and show them what we do as well, right? So as I said, I did this about 12 years ago. It gave me a very unique perspective on what I'm presenting today. Very much the same, but I've got data from 12 years ago, and I've got data today. And I see what the projections were 12 years ago, and we're going to look at the projections of what happened today. And we're in that projection of 12 years ago. And so we're going to look at the numbers and what really happened, of maybe what I thought was going to happen, what didn't happen, what did happen. So we're actually in a very unique position right here. So kind of there. I do like my clicker. So I don't have to worry about, I walk around very much. I'm very fortunate to have raised a lot of very intelligent students. People are very entwined in what we do. The head of Intel Oregon is one of my former students. This young lady here, her name is Lindsay McCauley Schleismeyer. And yes, I know how to say it because, oh, come on, right there. I don't know why it moved. Maybe it's on some timer today. She now teaches for me. And so I'm pretty respected that they want to come by and teach for me and work alongside me, and she's not the only one. That is going really quick for some odd reason. So I'm going to keep my fingers off of this thing. So I like to always start with some history, as I did many years ago. So when we talk about history of robotics, it kind of started back with the textile machine with Joseph Jacquard. In fact, we're pretty darn close to where one of these was originally at. In fact, right across the street on the other side, in the woolen mill. People don't realize that Thomas Kay, founder of Pendleton Wool, right across the street here, and they had basically one of these old punch cards to do some, make their patterns the same as well. So a little bit more history right here in Salem, that we were at the forefront of this many years ago. In fact, we're at the forefront of it today still too, which is kind of nice. Okay, now, down one click, there we go. Babbitt designed a gripper to remove hot ingots from a furnace. This is nothing new. In fact, we still do this. Maybe not so much in today's environment here in Salem, but we did when we had Sanyo here, when we had Siltech here. They use the same type of ingot grower, picker-upper thing, right? Basically a crane. But try to imagine trying to pull up hot molten lava, molten steel, or in this case, silicon that we did. Now, when we talk about the first real use of the word robot, everybody thinks robots are new. No, robot was actually by a Czechoslovakian playwright who came up with the idea that these robots were going to take over the world because humans let them do everything for them. I see such a thing here, and it gets to the point that literally the robots start taking people out because they find that humans are not wanting to do anything for themselves. They let the robots do everything. So the robots are like, well, what's the use of a human? So this is not 1920. 1920, I mean, this is a big thing. Again, a lot of people think, again, robots are something new. They're not new. It's just the concept of where we can do things with them and become more commercialized, where we can actually see them more in the household, such as your Roomba, right? Until it hits all that dog hair. Okay. Then we talk about the Maria project. Again, the Maria robot and Metropolis were really, truly the first time, other than CPEC's play, where it gave human form. So when we were talking about droids, probably some of you remember Deep Space Nine and Data, right? The humanoid droid. This is where it kind of first came from. And if you've never watched this movie, you should. It's actually a very interesting movie. Then we see in 1928, Eric. Ooh. Big, big thing here. Have you ever played with those little toys that you push on the bottom and they kind of slump because they got, and you pick them up and they go like this? Yeah, that was Eric. But instead of slumping, he just had a bunch of motors going up and operating the arms and stuff like this. All in that base. What you see down there on the base of his feet is literally all those motors and stuff that were driving everything else. And you know what? We still do that today. Most of our robots, which I have one right down here, most of our robots in the motors are not up where you think they're at because it adds too much weight at the ends. And if you know something called sprung weight, if you ever heard about that terminology in a car, that's why we don't put motors on the wheels and we keep them inside so there's no sprung weight and it doesn't add too much to it. Well, same thing here. I think from 1928, I think that's a big step, from a big step there. And then we get into 1940s. I love this one. This is the Rollo. This was a robot that was supposed to do all the household chores. And what you're not seeing is Roy's Robot Repair on the backside of his shirt. I wear this jersey only for the fact that it is probably one of my favorite ones. I picked this up for $5. I like to go in certain places, and I respect Tektronix immensely for what they've done for the Valley and Portland. So that's the reason why I wear it. So again, the Rollo, the idea of what was going on here was pretty big. I mean, it was around the same time, well, 1950s, when RCA, maybe some of you remember that era, and RCA came out and did some ads about this is going to revolutionize the world. It's going to be the transistor. And they would show a flat panel TV that you were able to hang up. 1950s, they're talking about flat panel TVs doing it. The only difference is, just like in robotics and just like electronics that we're doing, the means to get there just haven't been invented yet. In fact, one of the newest machines at Intel for making the latest and greatest microprocessors took 30 years to build. Hear that? 30 years to build. That wasn't design and concept. That was 30 years to build. And now it's just now going into play to make the latest and greatest semiconductors that you're going to see out there. Same concept here. We just didn't know what we could do just yet. We knew what we wanted to do, right? I mean, I would love to be on a transporter one of these days, because I would love to transport to work, right? Be at home, eat my breakfast, go, oh, I need to go to work. Right? That'd be nice. But on my way home, I don't want to do that. I need to decompress, right? So I still got to drive pretty aggressively. No, I'm just teasing, right? But again, the idea of what we want to do is there. We just haven't figured it out yet, just yet. And I think that's the whole thing that's going to lead us into the future. In 1954, really the first programmable robot, and this is the catch, a programmable robot was by George Duval. It was this Unimate down in here. You can see this kind of gripper. Basically, it's just all big hydraulics. Just big stuff, moving a lot of things around. But you can move it, and it's all pretty much done by relays. And then in 1956, the Plano, put in place by Planet Corporation, was put into place. Again, marketed by Planet Corporation out there. Really neat industrial robot, but big. Big. Again, we didn't understand the miniaturization just yet. We couldn't get to those points to work with it. 1962, GM installs the very first one. This is, again, another Unimate here. They're showing that the robot could pour tea. If you think about it, it's kind of an interesting thing to see that they're already starting to think about robotics truly in the home. Okay? A lot of service robots out there. Then in 1973 was the very first mini computer. Now this is important because it really took the power of the computer systems and gave it some motion. Okay? Think about what we're talking about today. Gwenella mentioned about AI, about what it's doing. Also, it's doing some really cool stuff, but when it takes the amount of energy to provide power to like a city of Dallas for like a week to make a little 5-minute clip of a kitty cat going meow, then it may not be the best use of that energy right now, but we're getting there. But here we're really doing some kind of neat things. And if you look at this, all these robots all still kind of do the same thing, right? I mean, you look at that robot, it has we call it the waist, and we have the shoulder, and then we have the elbow, and we have the wrist, and we have, we call it that because it looks like this. Okay? And this, we may have 4-axis, 5-axis, 6-axis robots. I think I've seen a 7-axis here recently. That just means how many movable parts on it. It also means how many things can go wrong. Yeah, so we're always concerned about that. So what is a robot? It really depends on who you are. If you're talking about at home, it might be your Roomba. That's a cool little robot. I like that robot. Things that people don't realize, that there's about 3 other filters in these things that they don't know about, and when they go bad, it's probably when the filter's inside. And you got to pull it apart a little bit further and clean out the stuff, or clean out the cat vomit, which is typically what happens at our house. You got to pull that stuff out. And you got to know how to take care of that robot as much as it is about just having that robot. It may also be maybe someone with prosthetic. It was amazing. I wish I would have pulled up this video for you. But the prosthetics have gotten so good that the company out of Kennewick, Washington, what is their name? It's a medical device company. Have gotten so good about being able to pick up the neural synapses of what's going on that they are literally being able to have people with their prosthetic arms move the prosthetic arms by just their motion of by what they're thinking now. They've mapped it out. That's amazing. To me, that is revolutionary. Having someone give it that literally it's them. It's no longer just an arm. So there we go. I will back up one more thing here. Gwen Ellen talks about all sorts of, my favorite things are the things I do which are for people. I like to do a lot of different things. And one of them was in regards to this prosthetic arm. Not this one specifically, but I had a young kid in Hawaii. He was a middle schooler who was born without a limb, about from here on down. And my brother ran a bike store over there. He was doing the Ironman competition. That was his gig. And this kid would always come into the store trying to buy new tires or something like that. It's local. But he had a missing arm. And they tried to work with the University of Hawaii. They tried to work with all sorts of other places over there trying to help this kid out because he's riding his bike like this, right? Now, robots. It's a 3D printer. A 3D printer is a robot to me. I've got multiple. I got about 20 3D printers at the college right now. Okay, because it's just a robot to me. As soon as I go through them, everything else. We designed a cup for his arm, a holder for the bike handle, and then PVC pipe went in between because we can cut it to different lengths. And as he grew, they can shorten it up or make it different. They can attach it. And it costs us about $1.50 to produce it, and it cost me $15 to send it. And he rides with it. So while we talk about maybe a robot that's actually using brain waves and stuff like this, a robot producing a simple device like that to make a child's life better is everything. Again, then we go over to this Terminator, right? T2, right? You go to the Shakespearean Festival down in Ashland. You go to Disneyland, Small World, right? That's all animatronics, folks. That's all what we do. In fact, we sent a kid down there 2 years ago who's now working down at Ashland for that stuff. That's all. That's their only job. Works on there all year round, getting ready for the next year. Isn't that kind of cool? To think that that's someone's job. He was in theater in Central High School and is now down in Ashland mixing the two things together that he liked to do. So we see a lot of industrial robotics out there. Again, you're going to see mostly in automation robotics with automobiles and electronics and service robots. And so there's our primary two different things. There's industrial robotics and service robots. There was a commercial years ago. I thought it was the greatest commercial in the world. A guy was at a car show and car dealership, and they were talking about what color he wanted his car. And if you know, has anybody seen anything with the Amazon Slate? You know what the Amazon Slate is? It's an all-electric little truck. You get whatever color you want, any color you want. You can have it graphed on in a moment in time. You can put whatever diagrams and stuff on the outside you want. And it's right around $20,000, a little bit more than that. Pretty good, 300-mile service. Well, in this commercial, they said, "What color do you want it?" And he goes, "I want it red." He wants it red. The guy goes on his tablet, goes boop, and then inside they pull up another side window, and here's a robot with that car starting to spray it red. Right? And all of a sudden the guy's spouse or significant other walks up and goes, "Well, I think it should be yellow." He goes, "Oh, yellow?" Click, and the robot goes back over and starts painting yellow, you know? So, but that's what we're getting to. The mass production is getting to the point of not just so much mass production, but mass production that's personalized because of what we do. Now, I always kind of lead out with what Society of Manufacturing Engineers, I'm sorry, I thought this was going to show up a little better in this, but a robot is a reprogrammable multifunction manipulator designed to move material, parts, tools, or specialized devices through variable programmed motions for the performance of a variety of tasks. We used to call them just blind idiots. not true anymore. They are much smarter in many ways. I bring up this one here because of the size of robots. The biggest robot we had at the college was about the M900 there. It was maybe closer to the M2000, but it wasn't a dual system like that. They did each weigh 2.5 tons apiece. They were at resting were 9 feet tall. They have a reach of 15 foot, which would means that if I started them up in downstairs building 4, which I exist, my friend who was at the time program chair, I'd move her out of her chair if it broke through the ceiling. And so it was one of those type of things that we decided not to put them in because just too big. They did come from Freightliner, and they used to move semi-trucks around up in Swan Island. So it was kind of one of my favorite things. Another instructor and myself went up there, and we brought a low boy. If you know a low boy, it's on those things. And people right during 5 o'clock traffic, worst time of the day to go up there to get robots, especially heavy ones. But actually the perfect time because traffic didn't move very fast, and we didn't need it to move very fast. And so we were going through 205 and all the way down, and the cars, when they did get to speed, they'd slow down pretty quick because they'd go, and it'd pace our, look at the robots and then take off again. So it was a lot of fun. But at 2.5 tons apiece, they were actually too heavy. For even some of the floor, which is kind of interesting. Remember I said about that thing from Intel, that thing that took 30 years to build? So the idea there, here, the same thing here, is we get to a point of technology, we think we have to build a factory to put this thing into, and so you come up with all the specs. And if anybody knows about Intel, Intel loves to build things, and if it doesn't work, they just tear it back down and build again. And which is what they had to do, because when the piece of equipment came in, it weighed, I can't remember how many more tons of weight. It actually bowed the floor, and it was too tall. And so they had lowered it down through a crane through the ceiling, and at that point they actually had to make a different part of the ceiling. They actually just tore down the part of the factory and built it again because they had to meet with the new requirements of the weight. So, the annual installations of robots by the world, which is very interesting. Again, you're going to see here, this is back in 2022, This is looking back, but here we have most of it's being done in handling right now. We used to be the #1 use of robotics was welding. Welding was huge. Still is. As you can see, it's #2 in there. Not so much as handling, and that's primarily by Amazon. If you go out and look at what Amazon's requiring right now, they're looking for so many people in robotics and networking and understanding the ties between the two of them. In fact, I just told someone today, a couple of students said, guys, there's 179 jobs out there right now. About 150 of them from Amazon Web Services doing robotics and networking together. I think you guys are going to get a job. And there you go, in Salem. I said, in Salem. So very unique. But I do want to kind of point out here, again, this is in 2023, the data from there. But welding was one of the biggest ones. We still see welding done a lot here, even in Salem. We have a place out north of Harbor Freight on Portland Road there, back behind there. They make, I now understand where all these things go. They make go-kart frames. Make go-kart frames, and they make them all the time, and they have robots doing them. Makes sense? I always thought, where do they sell all these go-kart frames? Well, I have a cousin who was a vice president of Dave & Buster's, and now he's the vice president of K1 Speed. And if you know what K1 Speed is, it's one place that your grandkids will want to go. It's up in Portland. You can go to Top Golf next door to it, but they have go-karts, indoor track racing. I understand what they have to do with these frames because I actually crashed one of them at a very high rate of speed last fall, and I cracked the frame. That's how hard I hit. So, but now I understand where all these go-kart frames are going. They're replacing things that happen to them like that. Now, if we're looking at again, where we're seeing them, electronics has taken a little small dip this year, last couple of years, but we're still seeing it. That's pretty big for the state of Oregon because we have something called a silicon forest, and that's up in Portland, and that's where a lot of them are going to be at in that area. Actually, we don't have so much down here in Salem and Garmin, but HP is completely robotic in many ways down there for what they do for inkjet cartridges. And you start seeing other things. Food, this is going to be, pardon the pun, a growing opportunity. I am not joking you. I'm going to show you something. I was going to bring a robot up here today. Unfortunately, it's about 5 foot wide at base and a little longer, and I don't think they'd want to have a bunch of mud potentially tracked in here. But I'll show you that picture here in a little bit. So here, again, some different ones in ATS in Albany, Garmin and Salem. We do a little bit there. Again, HP Corvallis, DW Fritz in Wilsonville. They are the #1 installers of robotic systems in the Northwest. DW Fritz does so much. Maduri Farms, oh my goodness, I will tell you, I loved COVID time. I'm sorry to say that, but what I mean by that is that during COVID, Maduri couldn't get people to go out in the field and spray. Now, what does that mean? You've got 8 people, if you've probably seen them in the fields, walking with backpack sprayers, exposed to chemical, walking through, spraying, joking, missing things, right? Oh, gotta go back, stomp some more on your crop, right? That's what you're doing, you're stomping on the crop. You got 8 people going by. Maduri took a really thing, now this is a real baby one. I didn't bring some bigger ones up. This is just a little drone, it's a little droney. It's a personal drone. I love it. It's upside down, that way. And kind of fun. It'll follow me around, take all my things from my YouTube and Instagram and everything else, right? That's what it does. But what they did was, if you're an agronomist, you understand potentially that different materials have different infrared signatures. Okay? That's how we used to find marijuana in the fields. Because marijuana has got a different infrared signature, and so we would fly our helicopters over looking for a different infrared signature, and we could find out where that was at. And guess what? Just send them out there to that location. Go, take care of the crop. Well, so does pigweed. Pigweed. That is something that's low covering, kills all sorts of crop stuff that you want. So what Maduri did was they sent out a drone with an infrared signature camera on it and mapped out the whole property out there and basically came back with the GPS locations of those just little weeds. And then they sent out a land-based robot with those coordinates, and it figured out exactly where it needed to go for the least amount of damage to the crop. Think about that. And it singularly spot sprayed each weed that it found. That's amazing. Now let's talk about what that means. The advent of the robotic system there. First of all, we have less crop waste, right? We don't have so many people trouncing all over things, right? We don't have the exposure to the chemicals. That's a big one, right? And we don't have as much chemical going into the ground, which as far as I'm concerned, very important. Okay, I'm going to show you something else here in a little bit in regards to how we could get rid of even that. Okay, so out there, Amazon and Salem does some robotics, more kind of again, overall, the Amazon facility in Woodburn, fully. Oh, it's all robotics. Okay, it's the largest single building in the state of Oregon. Square footage wise, it is the biggest one out there. We can't hire the folks. People don't realize that. Even if we brought back 1% of the stuff that we sent to China, we don't have the people. We have to be robotic. In fact, after the tariffs were announced, okay, a year ago, Apple made a commitment to spend $500, not million, $billion to build factories back here in the United States. That's their liquid cash, folks. They had $500 billion to build their factories here, and they weren't going to do it until they were actually pressured to do it. They got pressure. That means it's all going to be automated, it's all going to be, but there still has to be technicians to fix it. The jobs are going to change. It's going to be the way it is, and that's what we're seeing. So, and of course, agility robotics here in Salem. When I told you about birth to basically end, right? Right now, agility robotics is the leading manufacturer, the only truly manufacturing site of a biped. They're a full-on biped. I've got a video of this here in a little bit for you. We'll watch it because it's here in Salem, right by Amazon. Imagine that, you know. Now, I love Salem Police. It's because I get a couple of my students who work with them and doing their communications, and the students always get to drive their bomb disposal robots. And my students always send me pictures of them driving the bomb disposal robot. And they never invite me to come drive the bomb disposal robot. But it's really interesting because I actually got to look at it. Actually, I did drive it once, and it was kind of fun. But this robot is actually pretty good size. Okay, it's pretty good size. And what you're seeing there is you got tracks, but you see these little round wheels on the outside? It gives it a little extra base. It can literally go whoop and go up just about another foot in the air just to get enough. So they can actually almost pull out the light bulbs up there just about. Not that far, but in a small one that could do it. So kind of neat of what they do. Some of the local robots that we have here. Oh, come on. There is Digit. That is the one that's being produced here in Salem. This is Digit. Okay. Agility Robotics came out of a think tank from Oregon State University, so we're very fortunate to have them there. If anybody works there or has anybody that knows someone there, please have them get in touch with me, because it's been a tough thing to break into. I do have a small in. I have yet to, develop that, but we got a lot going on. So I do believe it's worthwhile to bring this up. Come on. Is it not going to play? Is there a play? Is there an arrow? Where do you see it? Oh yeah. Yeah, go and play. It should be embedded. Oh, well, if it's not, anyways, it talks about their 40,000 square foot robotic system. Robots aren't building robots right now. It's still people building robots. Their goal is to have robots building robots, and their goal is to make 10,000 robots a year. So this is truly the very first biped humanoid robot factory in the world. It's in Oregon, right? It's right over by Amazon, right off of, you're probably within 3 miles of it right here. You just go right up the way to, by Costco, well, before Costco was on the other side, over by the state penitentiary, the old area in there. Amazon's like right behind it, but a little bit further, the big facility for Amazon. Which, when I went into Amazon, just to kind of let you know how big that facility is, and Gwynellen, you can show your amazement with this. If we took every single Chemeketa building, they would fit inside of it with room. Every single building, that's including even inside of McMinnville and Woodburn, all of those buildings could fit with inside the one Amazon facility that we have here. I think that's pretty cool. Okay. So what do? First of all, let's talk about Chemeketa. Chemeketa provides that opportunity for students to explore, which I love, because that's what they allow me to do. Learn. I get to do that too. Succeed, and through quality education experience and workforce training. I had a president a number of years ago. I went to a retirement for a friend of mine, Mike McNicholas, and the president came up to me and says, "You enjoy your job way too much." I said, "Yes, you do. Yes, I do." She goes, "What's the secret?" And I said, "Well, obviously you don't get it. You pay me to play. This is my world." And I know Gwynellen said something about, I have my MBA. I love my MBA. I use my MBA. I don't have people, pull wool over my eyes anymore on certain things. But I'm a technician. I'm a technician at heart. I am a technician, and I will use 95% of my time, I'm a technician to solve things, fix things, and then 5% of it is management. Okay, maybe that's not what other people think I am doing, but that's what I try to do. So this is Baxter. Some of you may have seen Baxter before. He is a cobot. Baxter was originally developed in the United States by Rethink Robotics. They made their money and they sold it to a Chinese firm. Baxter's face went out, his screen went out, and it took me 3 years to get a replacement screen. Trying to get anything from there, and this was years ago. This has been about six years ago, so before COVID. So they're very, very tight on their restrictions of what they're allowing to come back here in the United States. They've got the material and they're not letting it come back. So at least this company here. So we still run Baxter, but he tends to stay put. Let's see, Intel, and the young man on the far right works for Salem Hospital. And you go, technicians at Salem Hospital, who calibrates all of your morphine machines? Who does all that? That's not the nurses, it's not the doctors. It's my folks who are making $90 an hour. You heard me right. Okay, so when you go up there, if you are working for Salem Hospital as a technician, you're making $45 an hour. If you get your BMET certification, which is basically 6 more classes, you've passed your national board, and biomedical equipment technician is $90 an hour that Salem Hospital will pay you. That's what he's getting right now. He owes me. Anyways, I love this idea. We'll be a catalyst for individuals, businesses, and communities to excel in diverse or changing environments. I love this. Some of you folks like going to wineries, right? One of my favorite ones is Illahee. I go to Illahee because Mike Morgan, who was my former dean, did some work up there. Brad Ford, who owns it, was a former classmate in South Salem High School. His dad, Lowell Ford, was a dean of students at Chemeketa Community College, and I actually worked in his vineyard as a kid when I was about 14 years old, pruning grapes and doing stuff for him. So for me to go to Illahee, it's kind of like going to a family home. Okay, so I go there, and I'll show you some up there that we do. So one of the things that we do is we wanted to develop this program that addresses the current and future needs of our regional industries, and this is where the robotics program came about. For many years, I was the quarter tournament head judge or head judge for First Lego League. And many of you know what that is. Lego kids out there making robots and stuff. And they actually, I will tell you what, you want to have some fun? You want to have some fun and volunteer? Work with First Lego League. Go to ORTOP, Oregon, ORTOP.org, ORTOP. And I will tell you, volunteer. You're going to be working with all these little kids from this age to this age, and they're just excited about their robots. They're excited about their skits. They're excited about all this stuff, and I love it. So I got involved with it, and I saw Legos, and then I saw robots. And I said, what's between, right? Same type of thing. Then along came to something called First Tech, and some of you may have heard First Tech Challenge. It's kind of like a battle bot type of a situation where they spend a lot of money on robots. And nothing wrong with spending a lot of money on robots for high schools, but when you're spending $15,000 to $20,000 on a robot for 6 kids, that is not sustainable. Not sustainable. And at that same time, another teacher, he now works at North Salem High School. He was at West Salem Titan, Greg Smith. If anybody knows Greg Smith, one of the best gentlemen in the world. Awesome person, okay? In it for the kids. And also winning, but in it for the kids. Him, myself, Joe Shepard from North Marion High School, and Bob Tisch from Sandy High School. We all got together and we said, we need to do something more here. What are we going to do here that's not going to cost $15,000 to $20,000? And Vex Robotics was out there. And we had already been playing with Vex already kind of in the past, but we said, let's organize it. So this was about in 2003, right in through there. And we started with 6 teams. okay? It is now 188 teams this last year. Okay? We have to hold it at the pavilion at the fairgrounds. We can't even hold it in gymnasiums anymore. We had to split it out. We were doing gold and silver and everything else, and now it's just one big competition for the finalists. It's big. If you ever get a chance to do it, it's coming up here pretty soon as well. Typically in March is when that competition goes on, and then they go to World's competition, typically Orlando or to Anaheim. And Salem normally sends at least 2 teams every year. Just saying. So again, when we started talking about, we saw the drive. We saw the needs of what was going out there, and we said, how can we develop this further? And that's kind of where our program came into place. In fact, it wasn't so much that we looked at this and said, oh, a bunch of kids are in robots, let's go make a robotics program and capture all these students, right, for FTE and everything else. It was like, industry's yelling for people who need robotics, and these kids are in robotics, and if we can structure this within the high school a little bit differently and give them credit for it, which is what we do. We give them credit for competing in the robotics program. They get 4 credits in the class. That's pretty good. Okay. It doesn't matter if they continue on or what they want to do. They've got 4 credits if they want to do it. So again, we started meshing these 2 things together. Now, this is an older slide, very much older slide. I have this one up here. I keep it up here for the history. If you look at this slide, there's a country that's missing. Which one? China. Yeah. We're talking back in the 1990s, 94 and 98. They're still doing so many things mechanically that they were not using robotics, because they have a lot of people over there, folks. If you don't know that, they had a lot of people to throw at things. And that's what was going on. They didn't need robots. They just had people, cheap labor that they can do. And if you look at Japan, that makes sense. All I gotta say is, if you own a Toyota, raise your hand. Right? Right? I've got 2. My wife just bought herself another one. It's amazing to see that back then they weren't even on the mark. And then when we look at it now, hang on, right there. This is operational stock, so just make sure you understand it. In 2022, we had almost 4 million operational stock robotics just running throughout the world. And when we look at globally, China is installing 290,000 robots almost every year. And I kept this one up here because the next one I think is the same slide, pretty close to it. But this is one of the most recent slides. 290,000 new robots every year. I'm just saying that they've got displacement of workers over there now too. Or are they? Are they just bringing in more work? They're bringing a lot of work over there. Japan's right behind them. We're, again, well, I should say right behind them. Japan is in a distant second, and we're trying to play with Japan. Right? Look at the rest of the world. It's crazy to think that that's how far they've come to be a leader in robotics in that avenue. I was asked recently on a podcast about what is one of the biggest growing trends for robotics, especially for, and I said it's entertainment. This is a big thing. Humanoid robots that look like us, people, whatever you want to call it, that's actually one of the biggest ones out there right now, especially in Asia. They're looking for humanoid robots for entertainment. And we'll just leave it at that. And that's a growing one there. I'm being honest. I got to tell you what's going on, because it's driving a lot of what's happening in China. Now, when we look at the China booms over, again, other nations, again, operational stock, again, that's in 2 million of that is just in China alone. Look at that. They have 54% of the robots in the world. So we're playing catch up. We're playing catch up in a world that was ours, that we were playing around with in the very first place. So a lot of people forget that the Toyota system, the lean manufacturing, was not a Japanese thing. That was a Bell Labs thing. It was after the Second World War that they didn't have any population to build anything. And we went over there and they listened to us and they said, hey, if you do it by lean manufacturing, you could do it this way here. Look at this data. You could, and they said, okay. And that's what we say, Toyota and everything else was, I mean, awesome. So again, a lot of ingenuity comes from here, and we just kind of give it away. And this is one of the things that we see right there. And again, annual installations, there's 295,000. United States, 34,000. But just remember that almost every single one of your Chinese companies is owned by the Chinese government too, so they can afford to do all sorts of stuff. In 2022, the operational installations in the United States was 40,000, just above 40,000. And in 2023, we dropped a little bit. We dropped about 2,000 in that realm, in there, 2,500. Okay, maybe we're being pretty good about how we install robots and making sure they're in the right place and doing that work. But again, one of the things that we do have to worry about. And again, I like working with my students, and there's some students who are building robots, designing on whether it's a robot that she built or the automation facility that we actually work with to teach beyond it. We call them roboticists, but honestly, HR departments don't know what that means. So are electronics techs. They understand what electronics tech is as a person who's going to roll up their sleeve and get it done, and that's what these folks do. So we like to combine things at Chemeketa. I really do. I see the need of the roboticist person who is going to be not just in electronics, but is also going to know some mechanical, maybe some design drafting out there. So they have to know everything out there. Again, to operate, test, maintain unmanned robotics or electromechanical systems. That is a beautiful picture I took with my drone, about a little bit under 400 foot. That was our blueberry farm that my in-laws had out in West Salem. They're not with us anymore, but I still like having a picture up there because it reminds me of even the blueberry farm there could use it. I think I got one more slide now. We'll go for a small break and then take some questions and stuff like that, and then I will continue on. Because I got some really cool data to show you. But where are some of our graduates? Again, a lot of them are self-employed. State of, okay, I'm going to refrain from saying what I say because of certain reasons. Leupold, okay, optics, got some people in there. HP, Matt Grills in Dallas. DW Fritz, marathon coach out in Eugene area. Panasonic, which was there but no longer, but still some of them moved over to Japan with them, and into Cincinnati. Pacific Rim Manufacturing, Harrico, Nosler, Deschutes Brewing. Again, my student who works there, dude. Okay. Pape, okay. Pape, which is really kind of interesting. Those are the ones who sell John Deere tractors. I'll have a picture of one later on of some stuff. Ebert's Dairy Products. Think about the automation that's going into cheese manufacturing and stuff like that. It's a requirement anymore. Gen Weld, Radiosphere, Garmin, Oregon Iron Works, Intel, Woodgrain, PPG. They're no longer the Pittsburgh plate glass that we used to have down off of McGilchrist. They only have the paint shop there on Liberty Road, coming into town from Kaiser. Wilco, Maduri Farms, and ATS. Now, one of the things I do want to point out, and we'll take the brief, we'll start taking some questions. This is carbon robotics. Now, I talked about spraying, right? I said we want to get away from spraying. right? Please, let's get away from soy. And in fact, I'm going to show you some stuff that we're doing with Illahee Winery and vineyards, and we're trying to model this for all vineyards, okay? Because you don't want chemicals on your vines. You don't want chemicals in your fruit. You don't want chemicals on anywhere, right? You don't mind the sulfur for doing stuff, but you don't want chemicals in there. Carbon robotics, that is a laser system on the backside. That's all network servers in the back of that red boxes with lasers, which are killing and basically burning up all the weeds. It's literally burning the weeds. It will, you show it the thing that it should look like today, and in the computer systems and its AI will target nothing that it's supposed to, and it's just going to burn them. No chemical. Think about that. 100% kill rate. Right? You go after it at the proper time. You don't go after it maybe real early. You have to go in, as your crop is starting to come up, and you give it the best times to kill it so that it can flourish. And unlike dandelions, you know what happens to dandelions? They grow and they take out everything else. You got to get them early so they don't kill out your grass. Here we go. Okay. So we are trying to take. This is our robot up at Illahee Winery. Beautiful view there. Students goofing around. But this is our 5-foot robot. It's an Amiga made by Farm NG. It's actually for competition. We were hoping to be able to compete this year, but we're not going to do it this year, primarily just because of constraints on our side. The Amiga there is sub-centimeter accurate, which means it will come back to that same spot with that accuracy of my fingernail every single time. Right there, it doesn't have any implements on it, but it can be outfitted with a laser. It can be put down with a rototiller on it. It can be put out there with anything that we needed in there to move up and down the vineyards. And that's a pretty good sized vineyard. They've got multiple spaces out there, and Brad's very excited for us to do it. But there is one thing. We have one area out there, if you don't know about that, the wines out there have one called 1899. Does anybody know about that one? Okay. It's actually not produced by any mechanical or new machinery, electronics. It has to be all done by hand. And so that's why it's 1899. Their claim to fame is they stomp on it, they hand put it into the jugs and transfer it and do bicycle pumps, and then once it settles and everything else, they bottle it, and then they literally will take it and put it on canoes. After take a wagon down to Independence on canoes, take it to Portland, and take off some of the stuff from at Portland. It's all done by hand. So the only way for it to get to Portland is it has to be done by hand, which is a 3-day trip for them. Just a neat little fun thing, and it is a very good wine. So one of the things that we had to do was make sure, out of respect, keep our robot out of those vines. Makes sense, right? So Brad's still on the thing that if we can get this fully going and show it can be really well, he wants to do like a 2099 variety, which will be all robotically manufactured. So, but that's kind of the fun thing there. I'm going to go ahead and stop it for a little bit here and take some questions. So you guys good? Yes. Oh. Okay.
Hi, this is Brenda. I saw another presentation about a robot that they're using agriculturally, and it was solar powered. Is this solar powered or not?
It's not solar powered. The amount of energy that's required for this would be quite a bit. On average, see in Oregon, on average throughout the year, you only get 4.1 hours of sunlight, usable sunlight a day. That's on average. Okay, doesn't mean during the summer, but like today or some other days, I'm not going to get very much. So you could do it, but it'd probably be sitting off to the side and have a huge battery bank, and it's probably only going to go out a little bit at a time and run it off and go back and recharge for another week and go back out and do its stuff. But I can see it being done, but not in this state, and that's the whole thing. When we run this robot up there, we found out that even the limitations on this one, it has an 8-hour battery life on it because it has 2 lithium-ion batteries in it. But after an hour and a half, we were already down to half. We were going up hills, and we didn't have any implements on it. We didn't have anything on it. It was already running down. So just the environment can do a whole bunch to it. So I'd be much more concerned about if it was level ground in Northern California, right? I'd do solar panels all day long. But here in Oregon, it might be a different story.
Hi, I'm Bonnie. This is great. I'm really enjoying this. It sounds, I'm wondering, the military applications, is that just a completely different world? And would it have completely different stats as to who's investing in it the most? And is there a lot of cross-pollination?
Oh, excuse me. So even with the Amiga here, there's been some talk of use of the Amiga in military applications for moving things around, that you can just give it a path and let it move through, do transport without stopping, so that you're not putting personnel at risk. Another one, maybe you see some smaller ones like this. They make them even much smaller for the military, for you send it into an area to go take a look at what's happening on the other side of the berm, whatever you need to do. But military is very much aware of what's going on in the robotic world. There's another one that's called the Flea, made by Boston Robotics. This is really cool. It's about this big, and it will literally jump almost like 12 foot, 14 foot, and go onto roofs. And it'll jump up and just move on, go out, jump up, jump up, jump up, and it can just fly, and it can jump down, jump down, jump down. This is, I mean, the advancements of where we're going with stuff right now, in part is due because of military. We all know that, military spending. But the reality is that we're now starting to see people pushing boundaries on a consumer level and a commercial level, that the government is out going, we didn't even think about that. Now we can implement it with what we're trying to do. So we are seeing a lot in those realms too, big time. I can see where they could be even worse. Oh.
Hi, I'm Nili. You focused mostly on physical robots, I mean, that are built and produced. What's the difference between that? I'm from the finance industry. What's the difference between that and robotic process automation, for example, when you run a business process and...
Like Bitcoin?
No, I'm not taking Bitcoin, I'm not there. But just cash management, where things need to be processed either by hand or spreadsheets and are now done by bots.
Well, again, you're thinking about the thought process and the software aspect of stuff that can be done. And when I say Bitcoin, I'm not lying. I'm actually talking about data miners, which are doing the same thing. What people don't understand about Bitcoin, what we're looking is for large transactions. Large transactions. If you've done your taxes recently, in the last couple of years, you'll notice that you don't have to put in the pennies, right? Because to the government, in the grand scheme of things, pennies are what? Minuscule, right? But this is what those bots are looking for. They're looking for transactions which have been rounded up, and they're going to find those transactions that have been rounded up, and they're going to say, hey, there's 40 cents that person didn't claim because they rounded down. So that 40 cents is now mine. I can claim that 40 cents. And that's what they're doing. And so when you're talking about Bitcoin and that type of stuff, that's what they're really looking for. And that's the type of data miners that you're kind of looking at. But automation in general, you know, I will say this, I'll date myself on this one here. I remember DOS, I still teach DOS in many ways, and I had something called, you know, a dot batch file. And what did my batch file do? It ran multiple programs at once for me in different orders, so this process this and this process, because I didn't want to sit there and do it. So I just transferred the file systems between each other. That's automation. It's been going on for a long, long time. And I mean, I think this is one thing that a lot of people forget, that we get some really, really smart people in these jobs, and they learn how to automate things or make it much more efficient. In fact, a friend of mine who works for me now, he's very good at his job. to the point they actually gave him 3 jobs. And when he retired, it took pretty much 4 people to do his job. No joke. But he became so efficient at what he was doing. Not that he's a bot. He is building me an R2 unit, though. So I'm hoping that R2 unit will be here one of these days. Next time we come out here, we'll have an R2 D2 unit. We had one prior, but that went somewhere else. But, you know, it's just in that it's in that process. It's doing the same type of things, but truly with robots for us, it's in regards to the physical nature stuff. But we do consider those bots.
Hi, this is Dee. Personal curiosity, driving to the coast on the right, Maduri Farms now hiring. And I said, oh, I'm not up to strawberry picking. So you can see some buildings way off there. Could you tell me what's going on in those buildings?
In those buildings, yes. If you go to Harry and David's and you get dried fruit, that's what's going on in those buildings. It's interesting because that building I see from my second-story house, second-story my house, because I have a little small farm out there. Now, what they do is that they're actually taking all the fruit from around the world. I mean, we get semi-trucks of blueberries from Portugal or from Brazil or wherever else. We get a lot of fruit from coming up, because what's the growing season around here? Not right now, right? And they're still producing, and it takes some time. So what they do is they dry the fruit there in great big batches and great big huge dehydrators, and then they actually, all that water from processing is then shipped down to the old Rickrell dairy, and it goes into the wastewater treatment facility there. They were trying to make renewable energy out of it because it had methane in it and there's biodigesting there. The problem is that 3M, luckily, I'm going to say, I'm going to call 3M out on right here, and I'll look right at the camera. 3M, you're on notice. And the reason why I said, because they undersized the digester for them and oversized the engine for them, and they couldn't produce enough methane to turn the engine over to make it work. They sold it to them for $2 million. Maduri Farms bought into it with all intention of going like Bernie and Calgon Farms. He's not there anymore, but right there before Hopewell Road on Wallace Road, there's an old dairy right there, that's Calgon Farms. And Bernie was doing the same thing. He was taking his manure and converting it into methane and selling it back onto the grid because he had a neat little V8 454 Chevy engine in there that was converted to it. That's what Maduri was trying to do. But they got $2 million into it and they weren't able to do anything. They actually offered us the engine. I said no, because it was a 12-cylinder engine about this big here, and it really took up too much room. But Louis was going to do the same thing at Rickrell Dairy. He was going to take the waste product there and do it. And then when he found out that what they did to his friends at Maduri, he was like, nope. So, but they take the fruit, they dry it, and then they inject it back with flavorings or with sugars and stuff like that. So you make all this beautiful dried fruit that you get to make fruit cake with. And anybody who says anything about fruit cake, trust me, I love it. Okay? I love it. And I know where all my fruit comes from, could across my street. So, or Oregon cherry growers, kind of the same type of thing. They got some pretty cool things in there too.
Let's take one last question here.
Hi, my name's Rudy, and for the last 6 or 8 years, I've been watching the Japanese robotic convention. And besides the entertainment and the people like robotics, it's crazy what people are doing. And what surprised me was the motorcycle people over there are really into it. But is there a convention in the United States and that is similar to that? And if there is there an industry If you're in the industry, is there a couple of days before it actually opens to the public where you can go in and view and talk to everybody?
So the question is there something similar to the Japanese robotics convention that we have here in the States? I would say the closest thing, I mean, there are some, and I know I've probably been invited to a couple of them. Probably the closest one right now would be CES, Computer Electronics Show in Vegas. I was just there. I didn't go to Vegas for that convention. I was there for an American Automation Conference, which was another one very similar to it, but more strictly on automation and robotics. So from that point of view, that one is one of the biggest ones around. I actually presented at that one this year. It was a lot of fun. I was a little bummed because I had it was during the first week of the term. I went down there on Saturday because I had to put together my robotic systems and my automation systems, and I worked Saturday. Couldn't get on to school because that's where I had it on the school. Couldn't work on a Sunday. I had to go do something else in Vegas on Sunday, and I actually watched a football game. It was kind of cool. And then on Saturday, Monday, and Tuesday, I worked. I did the presentations and stuff like that. But I was not able to go to CES. So my goal is next year is if the conferences are back-to-back like that, I'm going to just stay a whole week and someone else can teach my classes at that time. But there are some out there. BattleBots is now in Vegas. They actually have, if you've ever seen BattleBots and stuff like that, BattleBots is now in Vegas. They actually have a building there. You don't see too much on that anymore. It's kind of lost its, its hipness and its edginess, but I think that it's coming back too. So, but that's pretty much what's going on.
Okay, thank you. Let's take a quick break, and we'll be back for more.
All right. I had some pretty good, interesting conversations up here. I think one of my favorite ones was just at the very end, and thank you very much. Someone said, how can I get my grandkids involved in some robotics here? And that's always kind of the fun thing. My grandson just turned 6, love him to death. My nephew just turned 6. Yeah, my grandson and my nephew just both turned 6, so it's kind of weird. But one of the things I'll tell you to do is, if you find a little robotics kit, which you can get them, but don't just say, here's the kit. Say, I need you to build a robot that opens up the cupboard for me so I can open it. I'm having a tough time reaching down and opening a cabinet. Can you build me a little robot that might open up the cabinet for me? And boy, give them a task, because you don't know where that's actually going to go. That could actually lead into some major money for them down the road if they really decide to get into something bigger. But that's always kind of the fun thing, is give them a task to build. I think ORTOP.org for First Lego League is a great way of getting involved. Go to the competitions, see that type of stuff. Typically, they hold it up in Hillsboro, the state competition, and a lot of fun to go see them. Again, if you're volunteering for them, it's a totally different world. I did the volunteering at the Evergreen Space Museum for all its initial times there. I knew Del Smith. I worked for Del Smith for a number of years prior to that, and I had a little bit of favoritism from him, so it was kind of nice that we were able to use the Air Museum for doing Lego competitions. So if you imagine seeing a robot fields underneath the Spruce Goose wing, that's what we had. And then we had all the rooms upstairs, and we were doing all. And the robot competitions, just to kind of let you know, in those robotic competitions, it's not just robotics. Okay? Your team has got, there's actually 4 parts of the competition, all worth 25%. And so when I say volunteer, you should, especially if you've got a background in education and stuff like this, or public speaking, because in one part of it, 25% of it is actually the field competition. 25% of it, we actually bring these kids in, and they can bring 2 people in with them, typically their mentor and their coach, and we do a team building activity. We want to see how these kids are working together. Is it one kid that's just been strong-arming everybody else into doing what they want to do, or is it everybody working together? We want to see how they're working together, and it's kind of a neat thing. And when you're sitting there watching these kids, and you can't talk about what what's going on in there, because you'll let the competition know. So everybody's, and between each session, each day, it's different too. So it's really hush-hush. It's like one of the most top secret things I think has ever been held. And so there's that part. And then there's one about the robot build and programming. And that there's the third part. That's, again, 25% of the overall score. And the last one is they have to come up with a skit that talks about a unique implementation of their robot for a certain task that's generally across the state. They're saying, this is what we're going to do across here. How would you solve this with a robot? I think that's pretty cool. And so when people go in there and they say, well, it's a robot competition. It's more than just a robot competition. It's, in fact, they call it cooperation. Now, the reason why they call it cooperation is because we have folks who, I've seen some teams go in there and they are just 100% about winning, right? They are, I mean, they're about winning. But you got a new team right behind them doing some stuff, and this team's all about winning, and then they look back and these kids, robots, having some problem, and they're going like, well, you know, if you do this, and you do this, you can. And they help these teams out. I'm tearing up because when you see this, it's really kind of cool. It's really a very special moment in your life when you get to see kids who are completely about wanting to win, who are going to turn around and literally give up everything so that these other teams could also compete very well. A great thing to me to see. So. All right, so this is going to be kind of the turning point when we start talking more about data, and I'm going to put you all to sleep with data, but it's about informatics. Okay. So again, potential job titles. Again, this is from the state of Oregon stuff that you might see out there. Industrial engineering technicians. There's no such thing as robotics in the state of Oregon, as per se. It's one of these out here, electromechanical technicians. You may have heard the term. Mechatronics. Has ever heard the term mechatronics? Yeah, it's really big nowheres. And the reason why I say that is a phrase coined by a company that they have tried to take the industrial robotics and industrial automation and industrial stuff and say, well, it's a combination of electronics and mechanical motion, which is what we do. So in the state of Oregon, it really is nothing. In fact, Lynn Benton closed their mechatronics program down because nobody hired from them. Remember I told you about HR departments are the hardest things to get by? So if they don't know what mechatronics is, you have to, let them know, and I'll tell you what, it's really ingrained in their brain what electronics engineering technologists and industrial engineering is. So hence the reason why we see that differences there. So what does the current robotics scene look like? Again, here's the annual installations here right now in thousands of units. Again, this is worldwide. In 2026, we should see 718,000 new robots going. Almost 1 million robots. That's a lot. That's a few robots, okay? What's interesting is that this is nowhere near the IoT things that people put on their networks, which are compromised. We were talking about compromised networks earlier. There's almost I have my advisory committee, and on that advisory committee, I have people from Cisco engineering their Cisco networks. And they say there is no such thing as a non-compromised network if it's plugged into the internet. You are compromised. And just all you can do is mitigate, make sure that you're not the biggest target. So very interesting because we're putting 1 million of those type of devices on our networks every year right now. And that's people like yourself and myself and kids. We're just throwing them on the network without thinking. And yet 1 million of these things out here, we're like, wow. But we're tossing 1 million of these other devices on every single time. Just as a little thing, I did something bad. Go figure. I got something called Meshtastic. Has anybody heard of something called Meshtastic? Meshtastic is a way of making an alternative network for internet. And it's basically all done by wireless communications, and so you can still make communications and send text messages back and forth to your friends and whatever. It's totally encrypted, blah, blah, blah. It's supposed to be 100% safe. So I bought a couple Meshtastic nodes. I said, here, gave it to a friend of mine, said, here's one for you, here's one for me. We're going to test these out, and let's take a look at this thing. And I plugged mine into the campus network after I did a bunch of stuff, and I got a phone call. I said, hey, Chuck, are you doing something different over there? Because some stuff going to China. We got some pictures and stuff going to China. I went, ooh. It happens. Some of the devices that we're getting from over there, just on a side note with that, are compromised in transit, which means that the shipments are being moved off the side and they're replacing chips inside there to be duplicate chips, but they actually have malware already installed onto the chips themselves. And this is straight from Cisco. They were on that. Their big server racks and their big network systems. Some of the routers were actually done that way. They were shipped in transit. So you can see the growth here. And I really want to kind of point out this growth that we're expecting to see and still go. So where does that leave us? Well, back in 2012, okay, we were projecting, again, this is from last time I was here, folks. Okay, this is the last time I was here. 2012, we had in Oregon 3,723 people in this industrial machinery mechanics, i.e. robotics world. And we expected by 2022, well, that was 4 years ago, right now, over almost 5,000, with a growth of change of about, quite a bit of 1,000 people, and that's a 30% change. I don't really look at the percent change. It's like, what's the fastest growing occupation in Oregon by percentage? Does anybody know what it is? Wind turbine techs. Okay, wind turbine techs. But if you look at the growth by the percent change, there's like a 40% change. We're going to see a 40% growth. But when you have 256 people, 40% growth is only 100 people being involved in it in the next 10 years. But when you talk about healthcare and nurse practitioners, and you have 30,000 or 3,000, and you see a 10% change in that, that's still greater than that 40% change in the wind turbine techs. And so I'm always cautious to make sure my students understand, look further. Don't just take numbers, look at those relationships. It's the same thing here. I don't worry about that change, but look at the annual growth opening. It said 122 growth openings with 108 replacements, giving us a total openings of 230 in the state of Oregon per year. That's what they said. Okay. Well, this is now. So they were expecting what? 4,900, and we are now at 7,000. That's 2,000 more. Okay, I've got the same data on the next page here, so as you see it, and look at the employment. We're saying that we're projecting another growth of 1,000 to 1,200, with still about the same growth, annual openings of 114. Replacement, 622. Why? Baby boomers, we've been talking about this for the last 10 years. 20 years we've been talking about the baby boomers leaving and saying, out of here, but a lot of the stuff in here, they don't want to leave. They make good money, they enjoy their jobs. I try to get my students to work for food processors in the valley here. Why? Because you'll stay there forever. They pay you good, you get treated well, you got full time, you got enjoyable, you're putting food on people's plate, literally. But it's hard to do it because those people don't move on. One of my students currently works for Kettle Foods. And I'm like, oh, kettle chips. And he goes, because I used to have another student work there and always brought in big bags of kettle chips for us. It was always kind of nice. Always brought us the seconds. And this guy is like, yeah, he goes, I want to move into another position there. He goes, but they're not leaving. He goes, I'm going to stick around as long as I can until I find another job. If I don't find another job, I'm going to stay here because I really want to stay here. It makes sense to me. It makes sense to me. I didn't realize how big Kettle Foods was until I was back in Washington, D.C., and I went to the airport, Ronald Reagan Airport, and they're sitting outside of one of the places was kettle chips from Salem, Oregon. People don't realize how much influence Salem has had on the federal government. The FCC testing and stuff all came out of Salem, Oregon with Thrower and Associates many years ago. A friend of mine named Bruce Bothwell was actually the one who actually started the testing and did all the tests for them. So here's again those numbers overall between Oregon and where we're at. I think it's kind of cool to see that we're on target, really. We're above target. The growth that we thought we were going to see was right there, and that we're poised to continue to do it. It provides a uniqueness. I am very fortunate that my college saw and believed in what I was trying to do and stood by it. They could have easily said, you know, we're not getting as many students out. I was like, we need these people. Simple as that. But with these numbers here, it makes me go 600 people being replaced each year, just from replacements right now we're expected. I'm graduating 16. We have 600 openings. Think about that. We can talk about nursing. Why do they get paid so much? Because supply and demand. Greater demand on nursing. You don't have such a supply, higher wages. My technicians make between $70,000 to $90,000 a year on average, my folks. And I'll show you that data here in a minute. But the reality is that it's because of supply and demand. I don't have enough techs. Everybody's been told to become an engineer. That's great, but for every one engineer out there, we need 35 techs, and that's the truth. So, in fact, it was not too long ago. If anybody knows what an H-1B visa is, where you can have someone come across from another country to take a job here, that if you had to prove that you cannot find someone here in the States to do that job. It was back in 2010 that they actually said that we could not find technicians for certain jobs, and they actually allowed H-1B visas for 2-year techs coming out of India. So again, as I said before, look at the wages. This is back in 2012, that our industrial machinery people make about $31 an hour average. Okay, not too bad. In our electronics ET programs, again, it's 31. Everything's pretty flat. Well, now look at what the thing is, and this is the current rates. Not too much bad, not too worse, but $38 an hour, that's average. Okay, and that's what most of my students will probably make pretty much going in with a 2-year degree. And so when folks say, what should I get into? Well, any one of these jobs here. Now, it doesn't show very much growth in each one of these, but as you saw with the robotics stuff, we're going to see some greater growth here pretty soon. I feel pretty comfortable in telling people this is a good job to have. My first attempt at an NSF grant was shot down. And not because it wasn't a great idea, it was an illegal idea from the state, from the federal level. What's one of our biggest cash crops right now in the state of Oregon? Marijuana. And I wanted to go after a growing business for National Science Foundation. And my director at National Science Foundation came up to me and said, you know, Chuck, it's not going to get funded. You got to pick something else. You got to do something else. I said, really? And they go, it will never get funded. Not here. Now, maybe recently with Trump's new change, declassification of it, maybe we can get it funded. But the reality is that it was never going to get funded at that point. Instead, we did something called Eat, Drink, and Tech. It was for the food and beverage industry in Oregon. And we were supporting things such as Maduri farms and the food processors and the wineries and the distilleries and the breweries. I never had so much fun on a grant visiting places than I had with that one there, because I got to go to all those places, and I was being good, but I got to go visit. And one thing that we found out was cooling systems was the biggest concern of all those businesses. Cooling. They always undersize the cooling systems off the bat, and then they grow, and they don't resize their cooling systems. So, all right. So again, good money there. Back here. Now, just to kind of put it into perspective, the top thing is the average wages across in the state of Oregon. Median wages in the state of Oregon is $26 an hour. Average wages. Again, I think that $35, $37 an hour, which is above that median wage, is a pretty darn good increase in it. We see a lot of students who, you know, they love their job, and they'll be along the line saying, I want to ask for a little bit more, and they get it because they understand the supply and demand. So we do offer a 2-year associate's degree in robotics. It incorporates the machining, the drafting, the welding, the electronics, and the soft skills. That's really an important thing to us about soft skills. I have a class that we try to teach them in a actual work environment how to talk to people about not what did you do, but hey, you know, can you explain to me what was going on, what was happening when a time that this failed? Trying to pull out the soft skills. And we got some folks who are returning to school after a couple of years being out there in industry and kind of rigid on the edge, and we're trying to soften that up a little bit. And again, as I said before, this is old data here. Electronics, you see we're still up in that area for that electronics and automotive. And when we look at it currently, automotive's kind of taken over. Just by a little. We're going to see that, I think they're going to bounce between each other. But it's been really hard. The one that I'm really interested in seeing the growth in is that food. And as I said, the land-based robot that I showed you earlier, I think that's really going to change a lot. We cannot do it with the population that we have. There's going to be a lot of food production. It has to be done that way. And warehousing, shipping of again, robots. Again, another kind of cool thing just to show that warehousing, Amazon, biggest lead right there, folks. People thought Walmart was insane. I should have brought this slide up here because, again, I teach business as well. And for Walmart to make their money, they have to have almost 6,000 stores to make their money. They make about roughly $97 million each store each year. Okay? Amazon has 200 stores, and they roughly make a lot more than that per store. So when you talk about someone having to run to make money, there's Walmart. Okay? And you look at Amazon, their infrastructure is what they're paying for. And all they're doing is logistically moving things around for people. They make a lot more money with a lot less work. So when you talk, again, I pull this up in my business class and they're like, really? Look at the data. Labor cost reductions, again, for productivity for robotics. I think it's kind of interesting that when we look at the United States as being kind of dead center, who has kind of the biggest gains on us? As you can see, South Korea is still pretty much in there, but China is rapidly increasing. And again, Germany, China, and this is based on pretty much by per person that lives inside the country. So by tens of thousands of people and robots that are there. So this is how it's kind of mapped out. If we're looking at the basis of the United States being 0, the robots in China, because they have so many people, is a lot less. But you can see in South Korea. South Korea is really huge in robotics. And again here, collaborative and traditional industrial robots. Now, collaborative robots. I showed you that red robot, I call him Baxter, and that's a collaborative robot. And it works with us. It's not supposed to take my job. It's supposed to help me out, right? That's the whole thing with Digit. Digit is supposed to not take jobs. It's supposed to help people out, like move a tote from here to here, right? It's a 30-pound tote. Some people have problems with 30-pound totes right now. Okay, doctor, what we say is physically should be done. So whatever Digit can do is what a human should be able to do at that point. And so, again, that's a cobot. And as you can see, in 2017, industrial robots were pretty much it, with some collaborative robots, and that's pretty much Baxter's. But look down here in 2022 now, industrial robotics are still growing, but that collaborative robot systems are actually taking a pretty good chunk right now. Kind of neat to see that we're actually seeing collaborative robots. Now, I went to Spain for another conference last year. They paid for it. I was real happy about it. I didn't realize how much of a rock star I was until I dropped into Spain in Victoria, and I had people talking to me from left and right. It was kind of fun. I'd worked with these people for 25 years, but I'd never been to their facility, so it was kind of fun. But what I'm getting to is that we have this thing called Industry 4.0. And Industry 4.0 is basically the idea of bringing everything together and everything being interconnected. So we know exactly how much is being produced in one factory versus another factory and everything else. But Industry 5.0 brings back the human aspect back into it and making a collaborative work together. And how does it actually benefit the human and not just making money? And there's where Industry 5.0 differs from Industry 4.0. Industry 4.0 is about making money, and Industry 5.0 is how does it benefit the human? And I thought that was pretty cool. So, in fact, that's what I kind of spoke about at the American Automation Conference. So if you don't know what a robot is, I'll kind of flip through a couple of these here just to kind of show you some stuff here. This is a gantry robot. And this could be moving all sorts of stuff. It's also a 3D printer. A 3D printer is a gantry robot. It's a pretty simple thing. We have this is called a SCARA robot, just different motions. And basically, think about the range of motions. We call it kinetic structure on it, things, and how it differentiates each robot from it. So this one can turn at the waist and move in and out and go up and down pretty much in limited motions. This is a palletizing one. I think this is really cool. Those are all suction cups on the arm, and it's picking up glass. Moving it from one spot to another. Another, this is actually another SCARA robot. Has some twisting in the arms. It's a FANUC. If you want an expensive robot, there it is. Most are FANUCs, so people go, well, I want to get a nice robot. Yeah, your basic FANUC is going to cost you right around $100,000. Okay. I just bought one this morning, not a FANUC, from a little shop for about $1,000, but it's only about this big, and I'm going to use it for teaching to do some stuff. Another SCARA robot there. This is for medical. If you get anything from Kaiser Permanente, it comes from a robot that kind of looks like this. In fact, this is a good segue about this one right here. I haven't talked about any of the robots down here, but this is a neat little robot. Now, I truly recommend for anybody in this room, if you get a chance, and if we can get a chance, we have a gentleman from Salem. His name is Dr. Kevin Bataille. Nancy Bataille is his mom. Lives at South Salem. She was a teacher at Chemeketa, math teacher. He runs Brookhaven National Laboratory's research facility for drugs. Okay. He was at MCAT in Chicago. Kevin, if you ever see this, I'm sorry for hanging you out to dry, but he also texted me this morning showing me how much snow was in New Jersey. He does all the research for all the drugs, maps out the drugs. So we had to know what the structure is. This little robot was one of the 2 robots that was used to map out all your COVID drugs. Okay? And he did such a good job of being able to do the turnaround on those things that they said, Dr. Bataille, what could you use? He goes, I could use a whole new robot system that would be faster. And they go, done. And he goes, Chuck, do you want my old robots? I said, yes. And so we have them. It's kind of a unique thing to think that this little robot here, okay, it looks no different than really the one I showed you earlier, did so much for our society and stuff. Again, just a little fun little robot. This is a KUKA. I have a KUKA. If you want to find something fun, look on YouTube. You can find a video of a KUKA robot playing table tennis against a world champion. And it has to be programmed to do it, but I'll tell you, there's also parts of it which are not true, but the reality is that they are very accurate in what they can do. My KUKA, I call it the mean robot. It's 55 kilograms of meanness. When it wants to move, it's going to move and move you out of the way. And if you want to see relative size for this, okay, relative size of this robot you're seeing here. See those two squares on the bottom of that page? Those are forklift things. That's where the forklift goes in and skid. So understand that forklift's out here, okay? So when you talk about that robot, that is a big robot. Again, this is a parallel robot. You might see some ones in there like this. They actually have actuators that come in from each side and they can make a kind of this kinematic structure that looks like a bowl. And very neat. There are some 3D printers out there that use that as well. A lot of applications, again, as I said before, is welding. Big time for welding out there. Another one, again, that's welding. It's interesting in this idea of robotics like this for automobiles. Toyota, for many years, up through the 90s, had a huge issue when it came to windows leaking. They had a tough time with their windows. I don't know what it was, but what they did was they implemented a robotic system and took it away from the humans doing it, and they allowed the robot to come in there and just pretty much take the goop and like this, and the robot went in there, and they have lost 0 windows. They have had 0 leakages. Big difference, right? So it was really tough to get robots into the automobile industry because of the unions. That for the longest time there, you had to have someone watch the robot put the tire on for you. No joke. I like this one, stemware. What I think about was really cool about this picture is that it's upside down. Now imagine hanging one of your folks upside down. It's not going to be very nice for a while. It might get kind of cranky with you, but it loosens up, opens up so much of your floor space to do other things that you want. I like this one. I always think about Wendy's. You think about the Wendy's hamburgers or the hamburgers that you get at Costco, right, in a big bag. Yep, right there. Picks them up, freeze dries them, off they go. Another one of my favorites. Agriculture. Again, it's all over the place. This is transplanting of basic new seedlings from algae into maybe some other material to keep them growing. Now, why would this be, why do you think this would be kind of a really good thing? No germs. In fact, I could go through and between every single plant, I go back and I can sanitize it again, right? And I'm getting a consistent pressure on it. I'm not going to go in there and someone's going to pick it and break it and do some stuff, right? So there's a lot of really cool benefits to this one here. Now, I said I was going to bring in some autonomous tractors. This is from Case. Just know that Case, they did it after John Deere. John Deere has been doing it for a while. Really big in the Midwest where they have much bigger farms. We actually had one kid working for Golden Valley Farms in Monmouth area, and their GPS, right? They're partly done by GPS. Really necessary about GPS is that cloud cover doesn't do very good for it. And he fell asleep on the tractor because he wasn't having to do very much. It was supposed to be following a pattern, and it was cloud covered. And the tractor went through the fence into the neighboring nursery. Luckily, there was no product over there, and he caught it pretty quick as 12 bottom plow pretty much went into it. But that's there. Again, this is a fairly good one. This is an FFA convention just a few years ago I went to. A neat thing. If you've never been to an FFA convention, ever seen it in Indianapolis, it is a sea of blue. Very, very proud of those kids there. In fact, I just did something with the FFA last week. I did some judging for them. I judge 4-H as well, too. Now, this is one of my very first 3D robots, 3D printers. What's really unique about it is that you see what's on the bottom of that? Those are fingers. I had a student design for a friend of his a prosthetic. Remember we talked about prosthetics? He designed a prosthetic arm for his friend running something called an Uno, and he wanted him to have something to do because his arm had gotten repossessed. He wasn't making payments on them. So you don't get free ones after you have a car accident and waste your arm. You got to pay on those things. So he was working on it. All right, as I said before, Baxter, I had to wait 3 years to get a new screen. He looked like what's down here in the bottom, little face down there detached from his head. I was doing brain surgery. It was kind of cool. And some other service robots, again, you're going to see a lot of them out there in the next couple of years. But I think the medical robots are going to be a big one out there. This is one of them. This is doing brain surgery using the robotic system. Now the thing is, the robot's not doing the surgery. Robotic this time is allowing the doctor to do the surgery, but it moves when the doctor moves. If he wants to look at something, it will move around with them and so they can see what's going on. However, just recently was one of the very first actual surgeries done remote, fully remote. Robot on this side doing everything, doctor on the other side manipulating things through paddles. I think it's really amazing. I know that I'm getting down near time, and I'm going to go for a quick on here, but anybody have an idea what this one is? Sewer cleaner. Sewer cleaner, right off the bat. You got it. Who wants to go clean sewers? Right? But it is a sewer cleaner. It goes down there, sweeps it all, presses it all around. I will say that this one hurts me a little bit because I had a friend who was a blind gentleman from, worked at Salem Hospital. He did all the records and took them all around, Daryl Henry, and he walked with his dog all around there. And that's how he had a job, you know. And they were going to put one of these in there. They actually have these in there for doing the drugs around there, but because they now do all records digitized between there. And that kind of took the job from him, but kind of cool. All right, so again, service robots manufactured by the top of the countries. Again, we're talking about service robots in the United States. We do it when we're manufacturing, because it's about the creature comforts, folks, right? We need those Roombas, we need those type of things. But look at where those other ones, they're not producing as much because they're more worried about manufacturing, truly. And all right, I would say that one thing we want to think about, some dangers and risks of these. Again, this is a Mars rover, cute little thing. That had solar panels on it. It kept it going for a while. And I do think the drones and agriculture are going to be a big thing that we're going to see. These are robots. They are pre-programmed to do stuff. So I try to use my terminology correctly. Drones are when they're on a path. They're a quadcopter if they're not on a path, if they're not being flown autonomously. A drone is when it's autonomous. A quadcopter is when it's not. I do like the fixed wings here. I got a couple fixed wings myself. I like them because you can put a solar panel on top of that thing and increase the lifetime of that thing and catch the thermal rises in these things, and that fixed wing there can stay up there for hours. A drone's going to stay up there for 20 minutes, a quadcopter, because it's all by thrust. So these other ones down below, I think, and they're actually quiet. You can shut the motors off mid-flight and just let them glide. And then do all the imaging, perfect. Kind of what's going on there. So someone asked me about self-driving cars. Knew I was going to have it up there. Okay. And they're asking me about, where do I see about self-driving cars? And I said, well, electric cars, unfortunately, I see are going to have a very difficult time in the near future. And primarily it's because of national security for AI systems. AI requires a lot of water and a lot more electricity. And we have the infrastructure in for building of this, but we cannot use that electricity for the AI systems as we need. And hence the reason why that is going to be on the side burner for a while. It is until we put more dams in, other ways of nuclear power plants, like we got the new scale down in Corvallis. We'll get them back going more, but not until that actually happens, I don't think. All right, I'm going to leave it right here because I know that some people were asking me about this. If you are interested in going to some robot competitions, robotevents.com or top.org, those are really great sites that if you want to get involved or you want to take your grandkids or someone else, you want to go see some stuff like this and have some fun, watch kids bounce around, singing songs, having a good time, these are the ones to go to. A lot different than your battle bots. I'll open it one more time for some questions, and we'll go from there.
I'm wondering, do you have time to tell them about how you used some robotics underwater to help that legal situation?
So Mary Ellen's asking me about, I was in a conference one time, I was actually in Washington, D.C. at a NSF conference, and I got a phone call. And of course, this is how it always happens. I get a phone call, and it was City of Dallas, and they were like, hey, we have an issue with our water supply. Our buoy that marks our input in our Mercer Reservoir is not showing. So they didn't know if someone shot it, something happened to it, but it's not showing it. And all they know is they got a 24-inch pipe down below that may be clogging or getting clogged. And they said, could you take your underwater robot? Now this is my underwater robot. It's a cute little one, okay? Cute little one, it's an open ROV, it's one of the very first editions. I love this thing. I've since had students actually build bigger ones, because one was in the nuclear subs in the military, and he wanted to make his own sub, and I gotta say, Kroc Center was so nice to him because they took it out the day before the actual presentation. They stuck it in the water, and then they had to stand on it because it was too buoyant. They didn't. I told them to come out, put batteries, and they didn't. But once they did it, their water sensor went off, and water was leaking through. They made an unfortunate thing. So, again, had I had that one, it probably would have been a different story. But this one here can go forward at 3 knots, but backwards it can only back up at only 2 knots. So when you talk about I can't remember how many gallons of water a day Dallas was using, it was pretty much a 55-gallon drum a second. Okay, and so we did some calculations and we said, yeah, we can't do this one because it's going in at 5 knots. The fastest I can pull it out is 2 knots. It's going to go right down into Summers. Hag Lake, we were looking for downed sunken ships as per Washington County Police. Some people tend to get insurance money from those type of things if they want, and hence the reason why they asked us for it. We could go down to 333 feet with that one right there, much lower than I can scuba dive at. So yeah, we do all sorts of stuff with those type of robots there too.
Hi, my name's Mark. You had mentioned trying to get young people engaged in this. You didn't mention it, but there's a company called Crunch Labs that has a monthly subscription. They send a box of all the parts you need to build the various robots and assemblies. It's the guy that made the glitter bomb punch thief.
Mark Rober.
Mark Rober. It's Crunch Labs. It's his company, but he has 2 different versions. He has one for young grade school level kids and one for adults. So it's a monthly subscription that he sends out these different packages.
That'd be cool. Anybody else?
Well, I think we're at our time.
Good.
I'm
We're out
sorry.
of time.
But I invite other people to come on up and look at the robots up here and to ask other questions.
Yes, please.
Thank you.
Thank you.